Hello everyone. This moment I'm gonna to share you again about how to solve some question physics. This is I take from HODDER. Book for A and S level Cambridge International Examination. Okay, let me start about number one. But don't forget to subscribe. Yes, don't forget to subscribe and watching this video until the end. Yes. Okay, let me start from number one. Number one, a certain sound wave in air has speed 340 meter second. And wavelength 1.7 meter. For this wave, calculate the first question is the frequency and the second question is period. So I draw first about given by velocity as the 340 meter per second, and then we have about wavelength or lambda in 1.7 meter. Correct? Yes. So question A. So actually we have a formula of relationship between V, lambda, also frequency. We know about the that one. V equals to lambda times frequency. Correct? Yes. So if we find the frequency, one is frequency as the V over lambda, right? V as 340 meter second and lambda is 1.7. So I think 34 divided by 17, 2, right? Yes. Yeah. We have 200. Yes, 200 hertz. To make sure this calculation we solve with a calculator. Sorry, 340 divided by yes, correct, 200 hertz. Okay. Now about the other question. On B question. On B question we have question about period. So period actually 1 over f. This is so easy. So same thing with 1 over 200. 1 over 200 0.55. Oh, mistake. No, 0.005. Yes, second, or we can say this is 5 millisecond. Correct? Yes, 5 millisecond, the period of this wave. We gonna finally we done for number one. So continue to number two. Yes. Let we read first about the question is the speed of electromagnetic waves in vacuum on air as 3.0 times 10 power 8 meter second minus 1. So I read first. Number two, we have V as the 3.0 times 10 power 8 meter second minus 1. This is velocity of the electromagnetic wave in vacuum. Correct? Yes. On the A question, the visible spectrum extends from a wavelength of 400 nanometer blue light to 700 nanometer red light. Calculate the range of frequency of visible light. Oh, it's so easy actually. Yes. But we write down first about this is wavelength of the blue one is 400 nanometer. 400 actually 4.0 times minus 7 in meter. Why? Because nanometer is 10 power minus 9. Yes. Also, lambda of red light as 700 nanometer. This is same thing with 7.0 times minus 7 meter. So after we know about wavelength of the blue and red light, so when the frequency of the blue one, yes, frequency is V over lambda, right? Yeah, we change V as the 3.0 times power 8 divided by lambda is 4.0 times minus 7. So 3 over 4 is 0.75, correct? Yes. 15, 10 power 15, or we can say 7.5 10 power 14 in hertz. Yay. Get it? Yes. I hope you get this explanation. Yeah. If you can understand about this explanation, just comment and on the comment box. Yeah. On the comment, please comment anything you want to comment. Now about frequency of red one, same thing, we use the formula V over lambda. V as 3.0 times 10 power 8, and then lambda is 7.0 times minus 7. This is 3 divided 4. I think we need calculator. Yes, 3 divided 7. 0.42. Yeah, 0.428. Yes, times 15, right? Yes, or we around this. Let's say this is 4.3. 4.3 times 15 in hertz. So we have ranks about frequency of the blue light and red light. Yeah. From 7.5 times 10 power 14 until 4.3 times, 4.3 first, yeah, times 10 power 15 hertz until 7.5 times 10 power 14 hertz. Okay, get it? Okay, thank you. You're watching until the number 2 on A and know about number 2 on B question. Okay. B question. The typical frequency for VHF television transmission is 250 megahertz. Wow. Calculate the corresponding wavelength. Okay. The B question. They asking me about the frequency of VHF, very high frequency, I think. Yes. 250 megahertz. So we know about megahertz is time 10 power 6 hertz. Sorry, this is 10, yeah. And we can say this is 2.5 or times 10 power 12. Yes, 8 hertz. Okay, until we know about the frequency, this one, yeah, and the speed of electromagnetic wave, it's constant, yeah, V as the 3.0 times 10 power 8 meter per second. So lambda, we can say lambda is V over F. We have 3 times power 8 divided frequency 2.5 times power 8 also. Yeah, we can cancel this one, yeah. 10 power 8 divided by 10 power 8 equals to 1. So 3 divided 2.5. I think we need calculator. Yeah? Don't use your brain to calculate this number because this is so hard. 3 divided by 2.5. 1.2. Wait, 1.2 in meter. Yeah, finally we get the V. However, frequency is they have wavelength as the 1.2 meter. Okay, thank you very much for watching until the number 2, and we going to number 3. But don't forget to subscribe. Please click thumb of the subscribe. Yeah. No, about number 3. Whoa. What is it? Okay. Let me read it about number 3. In your heart, please read it. Two waves travel with the same speed and have the same amplitude, but the first has twice the wavelength of the second. Oh, okay. Number 3, yeah. They're asking me the velocity, yeah, same speed, yeah, v1 equals to v2. So they're asking me about have the same amplitude, so a1 equals to a2, and but the first has twice the wavelength. Oh, lambda 1, this is twice of the lambda, sorry, lambda 2, yeah, twice of the lambda 2. Calculate the ratio of intensity transmitted by the wave. Oh my god, this is about the ratio of intensity. Okay, intensity, we have formula intensity of, correct? Yes, this is actually about, this is energy, yeah, energy, or we can say a t and 4r square, and E, yeah, or E energy as the a half of Ka square times T and 4Vr square. So in this case we don't have relation between about lambda, but we have relationship between them about amplitude. So if we see the amplitude 1 equals to amplitude 2, so that's mean I1 equals to I2. This is not depend by lambda, correct? There is no lambda here, so we can say I1 divided by I2 as the amplitude 1 divided by amplitude 2, right? Yeah. So because amplitude 1 same thing with amplitude 2, so we can say this is the ratio is 1. Yes, I think this is the best answer, the best fit answer, only 1. Yeah, there is no relationship between lambda but the intensity of light. Okay, I hope you understand this explanation. Yeah, yay, finally we go to the last number, but don't forget to subscribe this channel. Yeah, please subscribe this channel and give me a comment. Okay, number 4. We read it first about number 4. A student stands at a distance of 5.0 meter from a point source of the sound, okay, which is radiating uniformly in all directions. The intensity of the sound wave at her ear is 6.3 times 10 minus 6 watt meter minus 2. And the blah we have two questions, yeah, question A and question B. Better we read first about the something we get. Yeah, this is actually for the first is distance. We read as the r as the 5.0 meter. Yes, from the point source on which its radiation in a direction. The intensity of the sound wave here is intensity I as the 6.3 times 10 power minus 6 watt-meter minus 2. Okay. Question A. The receiving area of the student ear canal is, we have A, 1.5 centimeter square. Calculate how much energy passes into her ear 1 minute. Okay, we have about the time 1 minute. 1 minute, same thing with 60 seconds, right? Yes. So if they has question about the how much energy, let's say A, how much energy? Okay. I will break down for the formula about the intensity. Yeah. Now, intensity as the energy. Intensity as the power over area. And then power as the joule per second, ya, energi per time area. So if we want to find E, let's say this is same thing with A divided by 80, right? Yes. So A means I, intensity, times A, area, and times T. Yes. So we need to change this area in unit centimeter square into meter square. So we can say 1.5 times 10 centimeter to meter is minus 2, correct? Yes, minus 2 square. So this is minus 4 in meter square. So we back again about this one. I intensity, we have intensity as this one, 6.3 times minus 6, and then area 1.5 times minus 4, and T 60 seconds. Yes. Okay. So this is so hard to find. We need to calculator. So 6.3 times 1.5 and times 60. We don't push the power. 6.3 times with 1.5 and times 60. We have number 567 times 10 power minus 10. So the energy around 5.67 times minus 8. Yes, correct. This is about in joules. Okay, done for A question. Hooray, yes. Now the last question on B in number 4. Okay, I going to up. Yes. Let's read it first. Yeah. The student moves to a point 1.8 meter from the source. Calculate the new intensity of the sound. Okay, I have two position. Yeah, let's see. I read again about the position. The first position when the student has position is the 5.0 meter. Yes, here 5.0 meter. And the second one, they have position as 1.8 meter. and the intensity at the point 1 is 6.3 times minus 6 watt meter minus 2. So what about I2? Yes, we have about ratio about I depends on R, yeah. I2 divided I1 as the R1 divided R2 square. Yes, this is proportional with, yeah, I1 I2 I1 R1 R2 square. So I2 means R1 is 5.0. Wait, I2, yes, 5.0 divided by 1.8 square times 6.3 times with minus 6. So I think we use calculator, don't use your brain, yeah, it's so hard. Okay, 5.0, 5 divided by 1.8, wow, 2.7777, and then square, wow, 7.7160, and blah and blah, and then times with 6.3, that one, 48.61 times minus 6. So let's say we can use here, let's say 4.86 times minus 5, yes, watt meter minus 2. Okay, we done for numbers of the wave and the sound. Okay, thank you very much for watching this video. I hope you understand about the explanation area, but don't forget to subscribe in my YouTube channel and give the comment on the blank on the box of comment, yeah, and click the thumb like, and also about the ring bell. Thank you very much, and you can click in other video about the physics A or AS level question. Thanks you, bye bye.